Come on in. So I'm Adam Englander, and I'm here to talk to you about doing IoT with Python, specifically got Python IO. And one of the things I wanted to do first is kind of give you a historical perspective. I am not an electrical engineer. I am not somebody who does this full-time as a job, so I rely on other people to correct my bad slides. Who's an electrical engineer in here? All right, correct me on my terminology if I'm wrong, because it's improving every time I do it. There's always one electrical engineer. So kind of how I came up with this harebrained idea to use Python for IoT. So I was trying to learn JavaScript because as developers, a lot of us do stuff on the web, and we think we know JavaScript, and then we actually try and do something with Node.js, and we find out we know nothing about JavaScript. And that was me. So I want to learn JavaScript. Specifically Node.js. And one of the local maker groups, there's actually a huge maker group in Las Vegas where I'm from, they were doing something for International NodeBot Day, which is where people all over the world build little NodeBots. And I wanted to learn JavaScript and thought this is an excellent opportunity to learn JavaScript from people who are actually pretty good at it. So I built the Executioner, which is a Pavelbot, and Pavel's just a guy I know, but he made he came up with the whole plan for building it and put on the thing. And so this is based on Arduino, using Node.js to drive it through a serial port. So it's okay, but it's not fantastic. But what it did get me thinking is this is actually not so hard, right? I took a little electrical stuff in school, so I knew how to solder. I had to remember how to solder. But with the right tools, not so difficult. Gluing together some spruce or some pine to make the pieces there, and a couple little motors, and an Arduino, and just plug things in with a battery and you're done, right? It was actually fairly simple. We managed to build the entire thing and compete in a sumo bot competition within 6 hours, right? People who knew nothing were able to build these things in 6 hours. So I'd heard a lot about IoT and all this, personal robot stuff, and this actually got me really interested. The problem is that Node.js is not my primary language, right? I was excited to learn it, but spending time learning Node.js doesn't make me any more money, doesn't make me better at my job, because I'm a Python developer. Doesn't really help. And when I started looking at that, I've spent time doing Python PHP for the last 10 years as primary, and not a whole lot of talk going on about IoT in Python or PHP. Certainly more in Python than PHP, but it's a little weirder when you start getting into Python. So then I actually had a work problem. So I work for a security company, and we were trying to enhance and find other uses for our security system, so we decided to build a physical access system and try and get into that market. And so this is using our system, which that's maybe a little difficult to see, but that is a Raspberry Pi with some switches and a power converter and an electronic door latch. So using our system, you could prompt it to try and authorize you to get into a door. And we had an electrical engineer on our team specifically to get in the IoT space, and she tried to build it herself. She actually started building the door lock herself because she didn't know that there's just stuff out there you can buy to do that. So she was trying to do this with integrated circuits, building it all herself, mapping it all together, and she had taken months and still wasn't able to do it because our system uses a lot of cryptography. And if you've got tiny little boards, they don't do cryptography. They don't have the memory, they don't have the CPU. Generating large random integers is actually very CPU intensive. And you don't get the appreciation until you start working on integrated circuit boards as to how intensive that is. So she was struggling. She was really struggling. And there's not much that we could help her with because we're a Python shop, and she's doing C. So we're like, well, here's how it works in Python, and here's the concept, enjoy. And so I started seeing what she's actually trying to do, and I had some experience just being kind of generic IT at a hospital. And I knew that door locks, there's these standard door locks, right? You see them everywhere. There's one right there. There's mag locks, all this kind of stuff. And I know that they just operate on 3 or 5 volt signals that tell you lock or unlock, right? So you have this mag lock. It's got this giant power cord going to it for the magnet, but the thing that tells it to be locked is actually this 5 volt current, tiny, tiny little thing. So I thought to myself, I wonder if one of these extra things we have laying around the office, this Raspberry Pi, if I could do this in Python. Because I found, oh, hey, there's some Python libraries for doing just specifically for the Raspberry Pi. And so I built this with her help, because I'm certainly not an electrician. I don't know which capacitor goes where and which resistor goes in, but she did. And I built the software and got it to actually work. And it took a weekend. She'd been working on it for months. She was very excited to have to stop trying to talk to tech support for these board manufacturers because their stuff doesn't work. And the important thing is that I learned through that library that IoT and doing GPIO, which is turning the switches on and off, is super simple. I didn't realize it was just interacting with the file system. It is all it is, right? So if you want to do this, right, you can get a very inexpensive, what I call a starter kit, right? It's a lot of stuff that you already have and a couple things you need to get. If you want to start with a Raspberry Pi, right? There's not a Raspberry Pi here. We'll talk about that in a minute. I have a Raspberry Pi here. You can get a Raspberry Pi, right? For a new one, costs like 30 bucks, right? That's a Raspberry Pi. This is most of that starter kit, actually. You can pick one up for about $30. If you want to pick up an old one, you can get them for like 10 bucks, right? If you want one like this one that's like a 2011, you can get one for 10 bucks. Need a micro USB cable with an AC converter. Most of us have at least one of those around, right? You've got something to plug in a USB thing to charge something, and you probably get micro USB. A Cat5 network cable, not so prevalent anymore, but you can get one for $1. USB keyboard, you probably got one. An HDMI cable, HDMI compatible display, which most people have those laying around, and then an LED, right? To be able to prove to yourself that you can do this, that's all that you've got to have, right? Very inexpensive. You could probably do it for maybe 10 bucks for stuff you got laying around the house. If you want to get a brand new one, you don't need the network cable. You can do Wi-Fi, because the new Raspberry Pi, the 3, has Wi-Fi built in, and you could probably use a USB keyboard or a Bluetooth keyboard and a mouse and all that kind of nonsense. But that's how you can get started on the hardware. And if you want to do IoT with Python, you want to start with Raspbian. Okay, Raspbian is Debian for the Raspberry Pi. You can get it pre-installed. You can build it yourself. You can flash it. There's a million ways to do it. But it's super easy, and it comes with Python 2.7 pre-installed. You can install through packages, because it's using aptitude. You can install Python 3, 3.5 as a matter of fact, which is super helpful at points. So you put all that together, and you have a fully functional Linux computer, right? The Raspberry Pi, it's built on education, so it's actually a desktop. You can configure it not to boot to the desktop, which is what I do, because I don't need that. But it's a fully functional desktop, so if you're just getting into this and you're not a Linux administrator, it's really okay. You don't have to be, because you can boot up to a desktop and you've got just a Linux desktop computer that you can get to the regular terminal from, and you can just start executing commands and writing code in an editor on your Raspberry Pi, and then using Python to run it. Super, super easy. And the next part that comes after that, now you've got your computer, you have to be able to do things. So GPIO is what allows you to do these things. And GPIO is general purpose input output. So you have these, it's the stem cells of IoT, right? You have these pins on your computer that haven't been predefined as to what they're going to be. They can be input, they can be output. Sometimes they can be analog or digital. Usually they're analog or digital, but some of the more advanced systems allow you to do both. And their behavior is controlled at runtime. So you can purpose them however you need. And if you notice, kind of on the board there, it looks something you just plug a ribbon cable into. And a lot of times that's what you end up doing to get it out of a case. But it's used to control and transfer data to and from external devices, right? So this is how you're controlling devices. This is how you're reading sensors. This is how you're turning lights on. This is how you're opening doors, starting engines, moving, telling motors to start. And it's available on general purpose integrated circuit boards usually, but it's definitely available on your Linux-based microcontrollers. right? Like your Raspberry Pi, your Beagle boards. There's a bajillion other ones out there, but we're specifically talking about Raspberry Pi and the Edison today. And you're thinking, well, that's not super helpful because I write Python and Python doesn't do pins, right? But something I learned is that it's actually part of Linux. It's part of the kernel. I was doing all this stuff with Raspberry Pi. I thought Raspberry Pi had something special because I was uneducated. I thought, ooh, this is some special stuff I can do with Raspberry Pi, which means Raspberry Pi is cool. And I started doing some more research, and I found, no, it's part of Linux, right? Exposing GPIO is part of Linux core. It's not, it has nothing to do with your distro. It is part of Linux core. It's called sysfs, and you can Google it and look it up, and it will have greater definition to the things we're going to talk about today, but it talks about how to interact with GPIO through the file system, which means that you can do this in bash, right? And for me, this is powerful, right? Because first I'm like, oh, I've got to use Node.js because they've got all these drivers for all these things that I want to do. Then I found, oh, no, I could use Python because they've got some libraries specific to Raspberry Pi. And then I found out, no, all I need is something running Linux that has GPIO. I could do it in Perl or Lisp if I wanted to, right? Not that I want to, but that I could, right? Which means I can do it in Python. I can do any of this in Python, and I don't have to have a special library, right? I don't have to have someone that provided me out of the goodness of their heart with some Python library that's terrible because they're C programmers and they went, I'll just wrap it up in a Python library. It'll be super cool, because that's what most of the stuff that's out there is. And it's available in user space, right? So the root directory for how you interact with GPIO from the user space is sysclass GPIO. Now, if you ever take a look at that, you'll see symlinks everywhere because it's for stuff that doesn't live in user space, but it's exposed in user space through there. And it controls interfaces. It has control interfaces and pin interfaces. So there's things that you can do to make pins available and not available, and there's things that you can do to control pins. So a control interface, and the most specific one that you're going to care about is export. So what export does is it says, hey, there's a pin here. I need you to export it to the user space. And so if you do this handy dandy echo, and hopefully people can read that, if you echo to sysclass GPIO export, it will now create a GPIO 18 node, which is a directory that has stuff that you can now interact with the pin. If you use onExport, it does the opposite. It removes it from user space. Basically resets it. So right now we're just typing echo at the command line and we're doing GPIO, right? And then you have signals, right? So direction in a pin tells it, am I an input, am I an in or am I out? Am I going to react to a change in voltage, or am I going to create a change in voltage? Because in a digital system, it's all binary. If I have voltage, I'm on. If I don't have voltage, I'm off. Sometimes that's flipped, and I'll talk about it in a second. But that's how you're signaling, right? You're signaling a motor to turn on, or you're being signaled that a switch has been closed, right? You have the lack of voltage, 0 and 1. And so direction determines if it's in or out. The value is the value of the pin, 0 or 1, right? Now sometimes 1 can be low. It's kind of like if you went to the crypto talk a little bit, or sorry, the other talks yesterday talked about big endian, little endian. What do you start with? Least significant digit, most significant digit? GPIO is the same problem. Is on high, is 1 high, or is 1 low? In different systems, it switches. But you can actually change what that's going to mean inside the system. So you can change active low, so that if you're 0, if you have low voltage, then you're actually active as opposed to high voltage as you're active. And if it doesn't make any sense to you, it doesn't matter. Most of them, 1 is high, 0 is low. But if your stuff works backwards, you can fix that just by using active low. And so edge is another thing that's exposed, and that tells the GPIO when to write the value. So if your voltage is rising or falling or neither or both. And all that really does is when you go read this value, it'll change the value from 0 to 1 based on what you just told it. All right, so there's this file out there called value, and if you're an in, right? If your direction is in, you're trying to read a change, an external trigger, an interrupt, if you will, which is actually is interrupt. You need to tell it when it's supposed to do that, and that's how you do that, by setting the edge. And then again, we talked about active low, which is used to invert the effect of the edge, right? So sometimes you want voltage power to be, I want you to turn off when you get voltage, and sometimes you want it to turn on. You can switch how that works. So brings us all to Python access to GPIO. So what you just saw there was a bunch of file system stuff, right? We were doing cats of files. We were doing echoes to files, which means that all you need in very small text is open, read, and write, and you can do GPIO, right? Core, not even a library, right? We're talking absolute core Python. Open a file, open it as write to write data, open it as read to read data, and you can start interacting with machines. And that is the very basic way to do it. Yeah, question? Yes.
Does the system remember the state? Like, how do you keep the state of what you've initialized those to? Like, what's the wrapper? Do you have a model wrapper for that?
So the question is how do you keep the state?
Can you ask the operating system back?
The operating system knows the state.
But can you get that back?
You can read the values. So when you, and we'll get into it in a minute. I'll do a demo. It'll probably make a lot more sense. But the operating system is basically taking a lot of this electronics and electrical engineering stuff and making it just accessible by the file system. So if you say, I want this to be an in, you can actually go read that value that you set and go see, is it an in or is it an out? Do I need to go change this? A lot of times you say, hey, I want you to set this high, but you don't want to set it if it's already set. I mean, you can, it doesn't really change anything. But depending on your particular system, it may give a short little blip that you don't want by telling it to go high when it's already high, so you may get a quick change in voltage. So you can actually read the value and determine what it is and see if you want to change it at all. And actually, there's a little Python demo with toggle that checks to see, oh, I want to toggle it. So if it's on, I want to turn it off. If it's off, I want to turn it on. But this is not IoT, right? This is T. This is a thing, all right? IoT is a network of things. And one of the things that really, the reason that I really wanted to start giving these talks is I go to a lot of conferences. I see people talking about Internet of Things with Python and Raspberry Pi, and they're talking about, I'm going to build a client that goes and connects this other thing that's actually cool, and I'm just going to use, requests or use, URL lib to go control all these other things. But that's not what we're talking about. We're talking about being that thing that gets controlled by some other API, right? That's broadcasting out the value of a switch, of somebody interacting electrically with a device. And the way that I choose to do that, just simply because the nature of it, is twisted. Because it's been around forever, it works on Python 2.7, which comes pre-installed, and it is event-based. And it supports, out of the box, WebSockets. So I can have an open connection to something else that speaks WebSockets, and they can be interchanging data, and I don't have to renegotiate connections. And from a security standpoint, if you have a device that you're controlling remotely, especially let's say you want this thing to open your garage, very easy to do, right? Have you ever seen the button on your garage? It is a shielded twisted pair, hopefully. And it just gets a small voltage coming from that little thing that glows, that button that you push, right? You can hook that up to a Raspberry Pi and trigger that door to open remotely, right? Very easy to do. But you don't want people to do it, right? You don't want someone to walk up to your house and go, I'm going to go find what port this thing is on. I'm going to go tell it to do it. You don't want to open up a firewall so that you can go connect to it, right? What you want to do is you want to have a kind of a bastion server, if you will, on the internet, right? So that you can connect your device to a central place that's talking back and forth, and you interact with that central device that's not in your home network, right? So you're not exposing your home network, you're not exposing your Internet of Things network, but it's still able to communicate through a proxy. So you're connecting out, you're both connecting to a central point that is secure and safe, and no one can come into your private network that's where your devices live, because If you've been paying attention to the news for the last 10 or 15 years, right, people are watching other people's baby cams. People know what temperature it is in your house, right? There's a lot of insecure devices out there that are just kind of, oh, you can connect to me and you can read my values. So for the system that I built and what I've been using ever since, I use Twisted. It's got an event loop and a single thread, and it does asynchronous I/O. It allows you to do a web server, a file system I/O, and real IoT, right? So you can link devices together, all talking together and interacting with each other, as well as I can monitor the status of these things because they're actually just talking to each other via APIs. And there are some existing APIs, IoT specifications that you can connect to, very small protocols. You can do that with Twisted too, right? Twisted allows you to write any protocol. I've done quite a few protocol servers with Twisted, doing LDAP and Radius and other horrible, horrible old protocols. But you can absolutely do it. And so now it's demo time. So originally I was going to give you a Twisted demo using a Raspberry Pi, but my Raspberry Pi bricked during transport. And I'm not going to really complain about it because it is a 2011 Raspberry Pi, so it suited me well. And one of the reasons that I think there's a lot of things out there that you can use, I suggest Raspberry Pi because it's cheap, it's easy, and if you decide to upgrade, you can still use it for other things, right? It's a computer and you can use it for whatever. So what I'm going to do it on today is I'm going to do it on an Intel Edison, which I just also happen to have with me on my trip. But setting it up on the Wi-Fi network here doesn't really work because it can't interact with things because it's a true IoT device and not a computer that has GPIO. But what I can do is I can demo the things that we were just talking about. If I can get it to come up. Let me change my display preferences real quick because it should show up. You know what, I will just stop the presentation. How about that? And any questions while I'm doing this ridiculous nonsense?
Yes, what is your logo?
My logo? Oh, that's a rocket. It's a launch key.
Is that a company's logo?
Yeah, that's my company's logo. Yeah, because we actually do the idea for the company was built on was that of 2 missile launch keys, basically both verifying at the same time they want to do that. So it was originally created for doing transactions, and that is really weird looking. That's not good. So let's try optimize for, I don't know, scale maybe? That doesn't look any better, does it? Oh, right. I can see it on there, right. But up here you can't, which is really kind of a bummer. Let's see if this helps. No, it doesn't. That's awesome. Maybe if I go full screen, it'll make it better. Will it? A little bit better. Okay. So some of these devices, and even the Raspberry Pi, for a long time I hated the Raspberry Pi because you need a keyboard and you need a video and you need all this kind of stuff to hook up to it and you want to mess with it. You don't want to have to do all this crazy nonsense. But then someone turned me on to one of these, which is a cable that allows you to just connect to it via serial on USB and power it so you don't have to do all that. So it's like $10 from Adafruit. I would really suggest if you really want to mess around with this and you're starting to get tired of having to lug a keyboard and a monitor around, those are awesome. So this actually supports it directly through USB, which is the Intel. So whenever you want to talk with these things, you plug in a serial port and you connect via screen because it's going to create a serial port on your computer. So there's different ways to do this if you're doing it on Windows. It's pretty easy on a Mac, super easy on Linux. But the big thing you want to do is never forget to tell it what rate it's going to transmit at, because then you just get this garbage that you don't understand. So you connect your serial port, and hit enter one more time to let you know you're there. I can log into my machine, right? It works the same way on every board that allows you to connect via TTY, right? So never do this on anything but a demo thing. We just log in without a password. And so if you take a look at, right, here's a bunch of ports that are already set up, right? These are not the ones I'm going to interact with because they're not available to me. They're available through special nonsense on the board that comes pre-set up. It's GPIO, but it isn't really. It's actually stuff that is hard-coded, that's already predefined on the board that you can't change, but you can interact with it the same way you would. But one of the things I'm going to do is I'm going to turn on GPIO port 40, pin 40. Oh, sure. Oh, you can't see down there? Oh, that is.
You can try to resize it so your terminal is
Well, but the only way this worked is when I went full screen. I'm actually full screen. We'll just keep it up top.
It won't because it's going to kill off.
Right. Well, like I said, we'll just keep it up here. We're not doing anything crazy, right? So if I echo 40, I type correctly, which I'm really terrible at, by the way. If it were not for IDE, I would not be able to be employed. Right, so this is telling the operating system, I want you to export GPIO pin 40 to the user space, which you did. Complain about it. If it's already exposed and you write that, you'll get a wicked little error, right? It freaked me out the first few times. It's not a big deal. It means, oh, it's already there, which means it's probably set up wrong, which means you probably want to unexport it and reconfigure it because it might be in a weird state, right? So if you're not expecting it to be there, you do that, and it's not going to be there anymore. But if you do that, and then you check it out again, now somewhere down here you have a GPIO port 40. There it is, yeah. Right there. All right, so now we have 40, which wasn't there before, all right? And so now we need to tell it, well, what direction should you be? And we're going to make something turn on, all right? So we're going to do out. So we're going to echo out. GPIO 40. Direction. Oh, cap lock, so it doesn't help. It's not there. Oh, yeah. You're right. Caret. Hold on. Okay, so let's just, I'll do this real quick. That's not helpful. Clear. I'll just do clear every time. How about that? All right, so if we echo out, right, now we're out. And all you have to do is, if you really want to, you can just cat that value. And it tells you that it's out, right? So the system is determining that, and it's literally just the file system is interacting in a pseudo way. It's a pseudo file system that's interacting with the electronics saying, I'm in, I'm out. Question? I believe, honestly, that one, no one's ever asked me that one, and well, let's find out. Because I know that when you do the values, okay, invalid argument. When you do values, any non-zero value is considered 1, right? I had never actually tried it with direction. So it's pretty good at not letting you do things you're not supposed to do. But the errors are cryptic because it's the file system, right? What if I just truncate it? Okay. I have no idea. We can always find out. That's what demo's for, right? No. And so let's see what it actually says. So it's still out. Didn't change it. So since you didn't write anything to it, like it's not an actual file, right? So you're just giving it commands by writing to the file system, right? It's almost like a stream if you were sending it off to a telnet server or whatever. Sending it nothing doesn't tell it to change its value. And if you do, even if you do write or write plus, it's, it doesn't clear out the value. It says it's going to, go to the beginning of the stream and then rewrite everything. It doesn't actually work that way because it's just a pseudo file system. But I think we're still out. Yep. So clear. So now if I want to turn on the pin, and pray that the demo gods don't hate me. The reason I don't normally do demos with this board is because the Intel board does a lot of crazy nonsense that the Raspberry Pi does not do. It allows you to use Arduino backplanes and all kinds of backplanes, which means it's not just a GPIO port. It could also be something completely different. So sometimes it works better if you use their actual library than doing it this way. But I can set the value. A light comes on. If you can't see it, right? That little light came on, right? It's not that exciting, I promise. And there's some people clapping. There are people like, so what? You turn on an LED, right? Turning on the LED is a very simple process that anyone can do. What you can actually do with that is you can apply a voltage to something to turn something on, right? Yeah.
So you just open the garage door.
I just opened the garage door. Or I turned on my dehumidifier from the person who gave the talk the other day, to the talk yesterday, right? If you have a relay that's hooked up to a 110, has anyone ever used X10? A couple people, right? X10 is basically like I'm sending signals through your power to be able to turn switches on and off. And those are just sending signals to relays that are doing that. So you can remote control all your nonsense control from your computer. You can do the same thing here with a relay on any switch, right? You can turn on an air conditioner. You can turn on a television. You can turn on anything that's going to require voltage, right? These are very good for doing gates, right? I'm going to allow something through. I'm not going to allow something through. And that's exactly what's going on with your garage door opener. It's the same thing that's going on with a million different things. So if you've seen anybody who has automated drapes, that's literally just applying a 3 or 5 volt voltage to it, saying turn the motor on, right, and turn on this direction. And so the motor's going, okay, I'm going to open the drapes, and then it does it for a programmed period of time, and then it stops, right? You can do home automation with a Raspberry Pi, right? All these things are just standard. You can buy them. They're commodities now. The things to control your drapes, the things to control your garage, the things to turn your sprinklers on and off, lights, all this kind of nonsense. The one thing that you can't do on a Raspberry Pi without anything additional is analog, right? So you can't say, I want you to set this at 0.1, right? I want you to have a voltage level of 0.1 so that the thing reading it knows that I'm only supposed to be 1/10 of my full power, right? So dimmer switches, things like that, those require the ability to be something other than 1 or 0, unless they're really complex where you have to have a bunch of different pins that tell you what to do when you're 1 or 0. But that's a lot of use for GPIO that you really don't want to do, right? And so you can do the exact same thing. I don't know if you're going to be able to see it or not. In Python, I don't know if less is going to help or not. More. So I created some examples, and there's some file system examples, and there's some Python examples, and there's actually from the talk yesterday from the keynote, I actually did one in Curio that kind of works, where you can telnet, because unfortunately Curio doesn't have HTTP or WebSockets, but you can telnet to it and tell it to turn on and off and all kinds of nonsense by passing in little digits. I did that last night. But toggle, no? Oh, that's right. So these are set up differently. There's more than one, simply because they're different pins that I was using, because the pin space doesn't exist on both of them. All right, so what is GPIO 40 for this is, the range is like, I think it's 30 to 50 for the pins here on this board, and on the Raspberry Pi, they're like, I think it's 2 to 15. So they don't even match up, like you couldn't figure out a way to make it work. So documentation for the pin mappings is really a bitch, but it's usually available from the board manufacturer, right? Some of them are really easy to read. Raspberry Pi, they have a nice little chart. They say, like, they have a picture of the pins, and they say, this one is here. Not so easy for Edison. Edison, you can read most of that, I guess. Edison, you have to go get the diagram. It's a chart, and then you have to know what some of the terms mean. And then, but normally, if it just says it's an IO port, it maps to a number on the board. All right, so GPIO 40 is actually on this particular board. It is output 13. That's confusing. And that's the hard part right now inside of Python, right? If you're doing this in Node.js and you're using Johnny 5 or Cylon, somebody's already done this for you, right? Somebody's already built all the mappings. Somebody's done all this kind of nonsense so that you don't have to. But somebody had to be that person, right? And I'm excited in Python to have the opportunity to be that person, right? That can write this driver that can translate 13 to 40 for you, so that you just know that, oh, I've got this board, so I'm using this driver, and I'm going to turn on pin 13, and it knows that's GPIO 40. So you don't have to go read all this ridiculous documentation. Question?
Isn't there on the Pi a GPIO module?
So you can get, there is a module available from PyPy, RPy GPIO. Thank you. And it's basically just interacting with the file system at its root level from a C level, with the exception of what it's doing for incoming data, which is a thread, which can be ugly if you have a bunch of them and they're all having their own threads or constantly just looking for the change in the value. What I'm really looking for is I'm looking for something to use with asynchronous I/O, so that I don't have to pull these things all the time. I can use async I/O so they can say, oh, I just got new data from the file system, right? So that I'm not just sucking down CPU, just making sure I'm getting it fast enough, because if you don't pull fast enough, you'll miss it. It's really kind of a mess. So going directly to the file system or through some of the more advanced, like the Intel board has a much better driver. It's the MRAA driver. It's much more advanced and works a little better. But you can absolutely just use RPy GPIO, but you still have to tell it 40, right, or whatever pin it is. You can't actually go look at the number here and it works. You still have to know the mapping, which is not that hard. But it only works on Raspberry Pi, right? It does the exact same thing. It should work just fine outside of a Raspberry Pi, but built into it, you cannot compile it on a non-Raspberry Pi, even though it's just access to the file system. It makes me so angry. But to read and write, literally, it's file open, location W, file write value, file close, right? I could have made it probably, with open, all this kind of nonsense, but like super simple, top down, any beginning Python developer can do this, right? And you probably can't see this stuff, right? No. And here's some stuff to get it set up, right? So if it doesn't exist yet, if GPIO 40 doesn't exist, build it, right? And so, so long to type. So if you just run it in Python, and the demo gods are done cursing me, you can just turn this thing on and off, right? Up. So, like, super simple, right? And that's the very easiest thing you could possibly do in Python to do GPIO, right? I've got some examples using Twisted where it's a WebSocket, a server, and you can see the status, and you can click the button, and it changes it from a web page, and all this kind of nonsense. But I can't show you that today because my Raspberry Pi is dead, and this thing won't connect to the wireless. And trying to make that bridge network crazy nonsense to work, which I tried in my hotel room until about 3 a.m., didn't work out so well on the system. So I've got about 10 minutes, I think. And I wanted to go really quickly and kind of finish this up super fast and then get some questions. Maybe it'll work right. Okay. No. Now it's completely screwed up, so. You reset the HDMI? Oh, I took the serial port out. Let's try it. See if it comes back. Nope, it hates me. Oh, I know. I think I might know what the problem is. I'm on the wrong one. Let me get out of my slideshow. Let me fix it back because I actually told it to mirror, and I think that's what's jacking it up. It doesn't care. All right, awesome. It's not letting me do anything. Yeah, so basically the next thing to talk about would have been, can't believe I broke the projector. Let's get in here anyway. The next thing to talk about is there's different platforms, right? So, why is that still there? Uh-oh, did it figure it out? So, nah, apparently not. Platform comparison. So, there's a Raspberry Pi, right? It's got pros and cons, right? Its pros are it's moderately inexpensive, right? For a brand new one, it's around $35. If you can get a hold of a Zero, it's $5, right? But they are so far back ordered, and the U.S. is like, you have to order it from somewhere in Europe, and it will show up in like 6 weeks maybe, because you cannot order it in the U.S. They're completely sold out. I don't think they've ever had them in the U.S. They're just always out of stock. But it's a flexible platform, right? It can do a lot of different things. It's an actual computer. There's a lot of guides and tutorials, right? There's a ton of stuff out there. How do I do this on a Raspberry Pi? And how do I do that on a Raspberry Pi? And very little of it's to do with Python, but it's all basically the same thing once you figured out how to interact with GPIO, right? It's got a GUI interface, so if you're a beginner with Linux, not a big deal, right? It'll still work. It uses Aptitude as a package manager, so it's using standard Debian packages, which is a nice thing, because when you get into other ones, they don't. They have their own package managers, and that's kind of a pain. And it's a great starter platform, right? You don't have to throw it away if you're not using it anymore. You can turn it into a music streaming thing, or they have all kinds of crazy nonsense you can do with these things to use them in your house or whatever you might want to use them for. So if you migrate up, you can always repurpose it, and it's still useful. The cons are it requires a special cable like that to do away with the keyboard and the video, but it's not that big. It's like another $10. They're underpowered. Even the new ones are still pretty underpowered, depending on what you're trying to do, right? If you're just trying to flip some switches, not a big deal. If you're doing what I do, which is I need to be able to encrypt data using, a 4K key and random AES, CBC 256 or 512, that requires a lot of power, and it gets a little more messy. There's no built-in analog digital converter. So if you want to do analog stuff, you're going to have to buy an add-in board, which can be, then you start needing that like electrical engineering degree, right? They're a bit on the large side for what they do. This thing seems it's a bit on the large side, but you can get one of these that's smaller than a business card, right? It's not going to have a lot. It's not going to be easy to plug stuff in, but if you want to go production, you can go production with some of these other pieces because they get really tiny and you solder everything in and you're good. And it's an ARM processor. Nothing against ARM processors, but anytime you install something from Python that's a library, it is going to compile, and it may have a problem, right? You're not going to just download the binary and you're good. And it takes a while to compile things on a Raspberry Pi. The Edison, which is what we did here for the demo, x86-based Addon processor, right? So you've already got all your packages on PyPy built. It has ample power, RAM, and storage. It's using SSD drives, 4 gigs of SSD. It's got 1 gig of DDR3 or DDR4 RAM, multiple cores. It's super fast. This is the Arduino developer board, and so if you have ever kind of researched into this stuff, Arduino is the big thing that's out there, right? Super easy developer platform. This is compliant. You can slap backplanes on there and use whatever is available for an Arduino. You can use on this board. And they have drivers that allow you to access that. Documentation is a bit confusing. It's Intel. Actually, the guy that was in charge of the kind of the whole platform as an evangelist lives in Vegas, and I spent some time with him, and he's like, they never listen when I tell them the documentation is terrible, but they're Intel, and that's what they do. It's an evolving platform, so I could not get this. I was up till 3 o'clock in the morning because I couldn't get this demo to work, and the reason I couldn't get it to work is because the new Flash ROM doesn't work right. I figured it out, and I was like, oh, let me try the previous version of the Flash ROM, and everything works fine. So they still have problems. And the sysfs GPIO is what's flaky, right? Doing what I do, that's flaky. If you use their driver, it works fine. Coolest thing I've seen in a while is this thing called Lucy by Dronesmith. They're also in Las Vegas. And that's probably one of the only people that knows about them. But you can build unmanned vehicles. That's aerial or non-aerial without any real electrical engineering understanding. It just uses some simple scripting, and it's also based on the Edison, right? Their brain is the Intel Edison. Cons are it's a bit expensive, right? It's a few $100s, but it's a quadcopter. It's still in early development phases, and there's no real direct development. But what you can do is you can automate this drone and tell it what it's going to do using Python, right? You can write Python scripts, and that is its program on what it's supposed to do. Very cool, but super bleeding edge. There's chip, which I have not personally used, and I don't know anybody that has. It's not out yet. I don't know anybody that's used the beta, but they're talking about a $10 chip, right? To be able, it's going to have a Linux operating system, Wi-Fi, Bluetooth, right? Now it's low power and pre-order only. So, but it may be something to take a look at, because if it's $10, that's not bad. It is super tiny too. And BeagleBone. So BeagleBone Black is a pretty, it's kind of like halfway between an Edison and an Arduino. They've got all the crazy backplanes, but it's a little more expensive, like $50. It can be a full computer, although it's not great at it. It has an add-on ecosystem, a lot of connectivity, like a lot of analog ports. If you're looking for ports, BeagleBone is your thing, right? Because it's got ports everywhere. Onboard analog digital, right? It's low power, and again, it's an ARM chipset. So you spend a lot of time compiling if you're doing any of that. There's some further reading stuff, which you can't see. But basically just the websites for all these things. And I have some examples in my GitHub that have PHP examples, Python examples, Bash examples on how to do all this kind of stuff. And so that's A England under IoT examples. And you can, there you go, you can reach me on Twitter only, because that's the only thing that comes through is with the lack of hair as well. Like 5 minutes for questions.
Does the Edison Arduino compatibility include its the Arduino C programs? So is there a way to compile Arduino C on an Edison?
I don't know if there is, but at that point, why would you not just do an Arduino?
I guess.
Yeah, this one is basically, you can write Java, JavaScript, whatever, on the board and interact with the backplanes, which is the real advantage of that. Right? If you're going to write Arduino apps, it's cheaper and easier just to use it. And it's also going to be faster, right? Because you're not going through a Linux kernel. Arduino is going to be way faster at interacting with GPIO. If you need something that has like a high throughput, you want to stay on that board if you're going to write those C apps. But if you're like me, who doesn't have the time or the real desire to do a lot of C programming, you can do it in other languages with the same ecostructure or ecosystem for the add-ons. Question?
You wanted to add GPIO to your regular desktop. What would you need for that? Like the USB GPIO board, and then when you plug that in, would it automatically discover SysFS?
That depends. I've actually had conversations with people that said that you can just get a USB cable and stick the board up on there. It's going to require a driver for that board that's then going to interact with that stuff. There are a bunch of things that you can just add onto boards and plug them into pieces that are going to work that way. But it's all just going to be on how well that driver works and if it works for that particular brand of Linux.
If you wanted to do more GPIO pins than the Raspberry Pi has to offer, I don't know how many it has, but say you want to double down on that, are there things that are able to split those out or expand the GPIO ability?
So if you really wanted to get that serious, you may not want to use the Pi. Like Pi is a good starter, right? There's something like BeagleBone has just, it's got twice the number of pins and they're all GPIO, right? So there's other boards out there that are specifically for doing all of that. And the other thing you may want to consider too is, do you need all of that, or do you need to have just a few devices that are talking to each other that are doing all that? You may find it's just going to be easier and cheaper to do it that way than to buy a board that has 100 GPIO pins, right? Because at that point, you're kind of building your own thing. You've got something very specific that you're doing. You're not using commodity hardware. So like the Lucy is basically, they're using this chip for the brain, but they've got their commodity hardware doing the hard stuff, like making sure all the rotors spin at the same speed at the same time. Something that you don't really want to do on this board is not really made for that. But it's really good at talking back and forth with things and doing kind of rudimentary communication to other things outside of it. So if you're in a position where you need a lot of pins, you're probably getting something very specific, and you may want to take a look at a different option for that. Any other questions? Question?
The Micro Center here in Columbus says they have the Zero in stock.
Oh, nice. Unfortunately, I live in Las Vegas. Yeah, the Zero is that you have to plug something in it to get like a pigtail or something to actually get the GPIO, because there's nothing really exposed. Because it's just this tiny little thing about that big. But it's pretty sweet. I've ordered one, I just haven't gotten it yet. So. I ordered it from Europe, and it's still on back order for like another 6 weeks. Any other questions? Awesome. Well, thank you for coming out. It's been a nice little time. And thank you to the demo gods for not cursing me for another day.